All right, welcome back to the Nexus Podcast. Alon Dankner of the Technion Institute for Technology in TelAviv Israel is my guest. Alon and his co-presenter Nadav Adir gave a talk at Black Hat looking at the security of PLCs, in particular Siemens S7 line of PLCs and the protocol governing those. Their presentation covered 6 attacks that they developed against the encryption in the protocol. They were able to expose private crypto keys, lots of cool bad stuff if you're a PLC owner and operator. The attacks run the gamut, and Alon is going to explain them much better than I ever could. So let's get into it. Good to meet you. Thanks for doing this. I appreciate it.
Thank you for having me.
You bet. So tell me about Technion and your role there a little bit.
Well, Technion, one of the most known universities in Israel, and this is where I studied. Did my master's degree in computer science there. And at the moment, I instruct a student project. This is, by the way, how this research was conducted. I mean, students, bachelor's degree and master's degree. Over the years, we had several teams working on it. And my role in there is that I instruct them together with were my supervisor when I was a student, Dr. Sarah Bitan and Professor Eli Biam. We all instruct this project, instruct the students. Yeah. So this.
And how did you land on OT cybersecurity? It's not like the most direct path. Usually, people are looking at malware, vulnerabilities, etc.
Well, actually, I had to give it to Eli Biam for introducing me to this field. I was looking for topics for my thesis for my master's degree. And I went to the Technion and met some professors. All of them has really interesting topics, but this one research on OT security just really caught my attention because of the impact that this type of research has, and also about the technological challenge. It's not trivial at all to see what these devices are doing, and to know that the impact of this research can exceed much farther than our nice lab at the Technion.
Right. I know you've spent a lot of time looking at the Siemens product, and that's what we're going to talk about mostly, but just in general about the overall security of PLCs, what are some of the kind of weaknesses that you see over and over as you study PLCs and other OT devices?
If we talk in general about PLCs, we looked at Siemens for quite some time, and the reason we particularly selected their product is because they invest in their security. They have cryptography, they have awareness for these security issues, and it seems that their team, their company, make effort and invest time and money and the personnel to develop this stuff. And I think this is not something that you would see from, definitely not something you see from all PLC vendors. If you talk about other vendors, then you might see PLCs that use like unencrypted protocol, and it's it's a bit sad, but it exists. In Siemens, where we have security protocols and we have cryptography inside protocols, so yeah, there are issues with authentication we saw over the years in several protocol versions, security of the control program, that is Siemens attempt to encrypt it. We don't want it to move around in plain text. So this is something we looked into as well. And by the way, when we had like 3 talks, or I say 4 talks in the past 5 years, just to a quick overview of our work. So we started, our first work published at the Black was 2019. We looked at Siemens protocol in that version. So this was a topic that was directly related to the protocol. And the talk we had this year also looks at the protocol, but on the new version. With TLS, that we can dive into the details in a few minutes. And two more talks we had in 2022 and in this year's Black Hat Asia, we looked at a different angle of the boot process and the firmware of these devices. And we saw weaknesses there that relates to the fact that PLCs mostly don't use root of trust when handling keys, when handling the boot process. So this is another area where we saw potential weaknesses besides the secure protocols. So we got a chance to look both at threat vectors, attack vectors that come from the network. Mm-hmm. This is side of the protocols, and also from the device security perspective, to look at the boot process and the firmware and its hardware.
Yeah, I mean, I was at your talk, and I like the way you guys kind of eased into it, showing kind of like the history of the protocol and where it started in terms of encryption, where it is today, and that's kind of the foundation for you. For yesterday's talk was just kind of looking at the current version, the current implementation of encryption, and you guys were able to poke some serious holes in there.
Well, the development of this protocol is really interesting. Actually, over the past few years, it's really nice to see its development, because we know it started as a protocol without, it was designed without security in mind. So it had no cryptography, no authentication, no encryption. And where I started looking at these products about 5-6 years ago, oh my God, it's 6 years ago. So
time flies.
Yeah, didn't expect that. So we looked at a version that had cryptography, but was developed by Siemens. Mm-hmm. So they wanted to, like, a purpose-built protocol that supports their requirements, but non-standard cryptography. And this is, by the way, something we talk about in security, and we debate of using standard protocols compared to non-standard, like open source versus closed source. So
it's kind of a rule of thumb, like building your own crypto is not the best idea.
That's exactly my point. The point I wanted to get to. Yeah. So it's this is a security principle. You should not. Most of the time, you should not implement your own security. It's much better to use something that was tested, like TLS, known for many years. This is compared to implementing your own crypto. But you know what? Past few years we saw like these two versions of the protocol. One that was implemented and developed by Siemens team. This was in 2019, and now we see they use TLS, the standard open source protocols. And there's always this discussion in security whether you want to have a closed source protocol and closed source implementation versus open source. And you can each of them has its advantages and disadvantages. When you choose to use TLS, so you have a well-known protocol that was tested and is being deployed for years, but some people would say it's not perfect. It's not a perfect match for OT systems. On the other hand, some people would also tell you that if you use something that is purpose-built, you might receive the features you want, but then you must not rely on security by obscurity. You must not assume that the attacker does not know your cryptography and the way your protocol works. And definitely do not implement your own encryption and authentication primitives, because that would be the one of the biggest mistakes.
Do you know what drove Siemens to make that change? Was it just from existing research that's happening and working with folks like yourself?
I know that from time to time Siemens publish security issues, and two main studies that we talked about also in our talk was Rogue 7, the work we presented in 2019, and another work by Claroty. So in 2019 we showed that protocol Siemens designed had several security flaws. They did not implement client authentication so that any rogue engineering station can send malicious commands to the PLC. Another issue we found there is that PLCs of the same model and firmware version use this exact same hard-coded key, called it a group key, and it is shared between PLCs. In 2019, the research group from Claroty showed that they exploited memory vulnerabilities to fetch the firmware and find this private key. So I believe that these vulnerabilities led Siemens to redesign and rethink their security model, and it's probably one of the things that, or the main things that led them to use TLS instead of their purpose-built protocol.
Right. And then in the research that you guys talked about here at Black Hat, you're looking at the new TLS implementation and trying to break that, and you went through 6 attacks.
Yes.
During your talk. As I mentioned in the introduction, they kind of run the gamut, man-in-the-middle attacks, just lots of steps. Mm-hmm. And the ultimate goal is extracting the private key, right?
Well, part of it, it's like, stealing private keys is big, but ultimately we wanted to get to a point where we show that man-in-the-middle attacker can, on one side, damage production and manipulate the PLC operation, but on the other side, to deceive the operators and show a false state of the process. This is what we call recreate the Stuxnet effect. So this was ultimately what we wanted to show. And
it was a very cool demo that you guys showed too, where basically, I believe there were like 4 LEDs happening on the PLC, but within the workstation they're only seeing 1, right? And that was supposed to be the normal state.
Yeah, it was nice program that we showed the scrolling.
Yeah,
great demo that my partner Nadav prepared, and when the operator expected to see only one LED, only one LED on his screen, but the PLC shows that it is running a completely different program, but still, when you try to monitor. When you try to monitor the behavior of the PLC, you see a different state. It's something you don't want to happen on your site.
So I'd love it if you talked about some of the attacks. I mean, from a high level, I don't expect you to do a deep dive, but...
deep dive is on our talk.
On YouTube. Talk, and Black Hat will publish that for sure.
Yeah.
And we can link to that. People can find it. They're using TLS now. How much of this... and again, I want you to go through the attacks, but how much of this is a TLS problem versus kind of or is it a Siemens implementation problem?
Well, the thing is that our attacks exploited the key management, we call it the public key infrastructure of the protocol, which was implemented by Siemens. I mean, TLS is a standard protocol and it requires certificates. But managing these certificates is an issue in OT systems. You don't have all the same properties that you have on the internet. You have requirements that you must consider and adapt your security to those requirements. Our attacks exploited the fact that the S7 protocol moved keys around between devices over the network. As attackers, we show that we can exploit these provisioning processes to retrieve private keys. It's something that I really doubt, probably never seen in the IT world. I mean, a server and an SQL server would never give you its private key.
So take me through some of the other attacks and kind of the outcomes. Do you have a favorite one, or?
Well, our main attack was what we call PLC key retrieval. It's a network attack where a remote attacker can send this request to the PLC, S7 request, and receive the configuration of the PLC, which surprisingly includes its private key. This is probably the worst thing that could happen in a cryptographic protocol, to lose your private key. So this is a client impersonation attack. Since TLS requires the use of server certificate, but client certificates are optional. and Siemens PLCs do not enforce them, then any client can send this request to the PLC and receive the private key in return.
And is the key encrypted or is it in plain text?
It is encrypted,
Yeah.
and we looked into the implementation, reverse engineer this process, and we saw that the encryption is eventually protected using a password. And we also saw that there were a few layers of encryption. I mean, you couldn't just use a single, say, AES to decrypt this private key. You had to go through several layers of encryption that uses random strings that you can achieve from the same message.
Mm-hmm.
But eventually, the security of this key relies on a user-defined password. So first showed this decryption process, and we know that TIA, the Siemens client, can do this decryption. So why can't we? And this assuming we have the password. If we'll talk about the implications of this attack, so first of all, if you have the private key, you don't have. I mean, an attacker can do anything with this private key. Decrypt things, forge things, impersonation attacks. Really, really bad outcome. I'd like to talk for a minute about the password.
Sure.
Since the private key is returned to the attacker and the private key is protected by a password, this means that essentially the security of the key is, you can say, degraded to the security of this password. Now, this is a totally different world, because managing password is also an issue. And in large organizations that have lots of devices and users, stations, PLCs, managing this amount of passwords is a big challenge. And so most organizations either do not use passwords at all, or if they do, they have same password set for all PLCs. This increases the chances that the attacker knows the password. And of course, you have all the regular challenges that you need to cope with. So you have password stealers out there, and you need to protect against leakages. The fact that there is a single password, some sites use single password for all PLCs, only increases the chance of a leak.
And it negates all the other security behind it, all the good
Definitely.
encryption and
Definitely.
the good practices.
So all of your security suddenly depends on passwords,
Right.
which is something we believe can be avoided. Well, after we found this private key, then we wanted to show what an attacker can actually do with it. We wanted to reincarnate Stuxnet and show that an attacker can implement the same, let's call it, OT features of the Stuxnet attacks against the latest version of S7. Now, since the attacker has the private key using the attack we have just described, now he can launch a man-in-the-middle attack. He positions himself between the client and the PLC.
Right.
All messages go through the attacker. Now, the client expects to see the certificate and keys of the PLC, and the security of the protocol is based on that. But since the attacker has them, he uses them to fool the client and tricks him to think he is the legitimate PLC, because he has the keys and he has the certificate. So the client has no way of knowing that he's communicating with an imposter,
Right.
with an attacker. So this is how he fools the client. But on the other side, you also need to fool the PLC. But we said there's no client authentication. I mean, the PLC does not enforce the authentication of the client, and he does not validate its identity. So the attacker can do it in both ways. The messages from the client to the PLC go through the attacker, and the other way. This is an assumption.
Yeah.
And the attacker can, out of scope, the attacker can get to this position using common techniques. Since all messages go through the attacker, you can first manipulate the PLC. But now when the client asks for the status for the status reports of the PLC and of the process, the attacker can change these messages and put in it whatever he wants. He can present to the operators a healthy state of the process.
Mm-hmm.
So the screen of the operator shows that everything looks just fine. But when you look at the PLC, you see that some things are not right. And this is what you referred to earlier when you looked at a program that shows one LED, which is the legitimate, but actually shows that 4 LEDs running in the PLC.
Just like Stuxnet.
Yeah, exactly. So this is what we called the Stuxnet effect. We try to achieve the same impact.
What's a better solution? Have you seen a better approach than using that one password? Mm-hmm.
Well, we had a paper published in 2020. We designed this secure protocol for ICI systems. We really looked at the requirements of these systems, these unique requirements, and we know that we not live in a perfect world. We have legacy devices. We have system with multiple vendors. Could have in a single site, you could have PLCs of Siemens, Schneider Electric, Rockwell Automation, and etc. So we looked at these organizations and we tried to design a better solution compared to what we saw at the time. We listed all of the requirements of the system and designed this protocol that provides authentication and authorization with granular privilege, something that we don't see today. Also in Siemens products, this protocol does not require you to set 4 types of different passwords, for example, compared to what we saw in the Siemens products. We show how to manage these keys and show how this key infrastructure can be implemented instead of moving private keys around. So we use a ticket-based system, something that we see in an enterprise network, an approach that is also common and known and used almost every organization. And we adapted it to the needs of OT systems.
From an attacker's point of view, is there a certain level of knowledge or sophistication in terms of the attacker being able to exploit these issues? This is not a script kiddie issue, obviously, or does the password kind of turn that into a much simpler attack?
I don't believe this is a script key issue because you need to have some knowledge here on the crypto and on the protocol. Since Siemens used TLS, a standard protocol, unfortunately this makes the work of an attacker a bit easier because you can find TLS implementation very easily. You can use just OpenSSL, for example. And this is compared to the previous version that had proprietary cryptographic protection. We've had to implement the client from scratch, and also relates to what we talk about the open source versus closed source protocol. But still, if we look at what we did today, you have to know how the protocol works. Getting there is not really trivial. Also, our assumption is the attacker is already in the network and has network access. So definitely not something for a script.
Last question. I know you shared your findings with Siemens.
Yeah, we did.
Tell me about that and just what were the mitigation recommendations? Is there an easy fix here, or does it require another overhaul of what they're doing?
Siemens acknowledged our findings, and they are aware that it is possible to extract the private key of the PLC and decrypt it when the configuration password is not set. But the mitigation that they offer is to use their existing mechanisms. So they require the system, their customers to do this. We didn't talk today about the initial provision, but they're required to initialize the keys of the PLCs in a secure environment. It should be isolated environment, hardened environment.
Okay.
And for organizations with a large amount of devices, this is a lot of work. This is really a lot of work.
Right.
And with respect to time and personnel and also expertise.
Sure.
Think of an organization that, again, has many vendors. You'll need to learn how to secure your Siemens product and Allen Bradley's products and all the rest of your products. So definitely require to learn how to secure these products, and it's not so, I would say, not so trivial. Now, besides initializing the keys properly and securely, you also need to use passwords. So you must activate the PLC configuration password that protects the private key.
Mm-hmm.
And passwords must be unique and strong. So that adds more to the complexity. Now, we talked about a rogue client, right? So any client can communicate with the PLCs. To mitigate this issue, you'll have to set another password called CPU access protection password. It's obviously different from the configuration password. Also, strong password and unique password per PLC. So, managing all of these, I mean, we just counted 2 passwords for each PLC,
right?
And there's more.
Right.
There's more to it. Because you have to, you can also use know-how protection, which is another password that protects the control program, which we didn't dive into today, but it exists and recommended to be used. And there's also the password for a user in the TIA, which, by the way, could be an SSO, but still another thing to manage. This is really, really not trivial, and it's a big challenge for organization to adopt all of these practices and to teach their people to do things right. And I really, really hope that it happens, but I hope
it always comes back to the password.
I hope that it happens.
All right, man. Thank you so much. This is great stuff. Congratulations on the talk and the research. It's very impressive.
Thank you so much.
All right. Thank you. Bye-bye.